The world's biggest ships. Inside the incredible race to dominate the high seas. By Jennifer Barone. Think about some of the things you use every day: your clothes, your shoes, your phone or computer. Most of these items were manufactured overseas, and they were probably traveled to the US by ship. We live in an era where planes whisk passengers between continents in a few hours, so it may surprise you to learn that 90% of the world's goods still move by sea. Maritime shipping remains the cheapest and most efficient way to transport mind boggling amounts of stuff all over the globe. Most consumer goods are shipped in containers, giant metal boxes that can be picked up by cranes and loaded directly onto trucks or trains when a ship into port. Thousands of container ships shuttle these reusable boxes around the world. A single vessel might carry $500 million worth of clothing, electronics, food, and other products. The more containers a ship can transport on each voyage, the more profitable it is for the owner, which means shipping companies are racing to build ships that are bigger than ever before. The new generation. About 5 years ago, Danish shipping company Maersk decided to take container shipping to the next level with a new vessel. The company wanted a behemoth that could cut the cost of transporting each container by 30%, while using less fuel than existing ships. The Maersk team created a wish list hundreds of pages long detailing what they wanted. They took it to the world's biggest shipyards, which proposed various designs. Maersk selected their favorite design from Daewoo Shipbuilding and Marine Engineering in South Korea. Then naval architects and engineers from both companies worked together to finalize the plans. Michael Heyman, Maersk project manager, says the team realized that one way to cut fuel consumption is to sail more slowly. Then the engine doesn't have to work as hard, and there are additional fuel savings from reduced drag or water resistance. Slower speeds opened up new design possibilities. We were able to make the hull, the ship's frame, and body wider and more bathtub shaped, which helps with packing in more containers, said Hyman. Another big change came in the propulsion system. Maersk's lead naval architect, Troels Posborg, realized that having two smaller engines and two propellers instead of the usual one of each would be more efficient. Twin engines and propellers can spin more slowly and use less fuel than a single big engine and propeller to achieve the same ship speed. That was a quantum leap for container vessels, says Posborg. Once the design was drafted, the builders used computer simulations to test its stability. They modeled different distributions of cargo and rough ocean conditions that can put stress on the hull. In 2012, the blueprints for the new vessel, called the Triple E, got the final thumbs up. It was time to build the world's biggest ship. Steel giant. The main ingredient in a container ship is steel. The Triple E contains more than 50,000 tons of it, enough to build 8 Eiffel Towers. Steel is an alloy or mixture of iron and other elements, especially carbon. For the Triple E, the shipbuilders ordered steel mixed to their exact specifications from a mill near the yard in South Korea. They needed just the right recipe to make the steel tough enough to withstand brutal waves. Steel that's too brittle can crack under the strain and sink a ship. At the shipyard, automated machines called plasma cutters used gas superheated to 16,000 degrees Fahrenheit to slice the steel. Robots welded the cutouts, joining them together by melting the edges to form giant segments of the hull called megablocks, 24 in all. A crane lifted the finished megablocks into place, and another set off welding robots melted them together to complete the hull. Maersk engineers checked the strength of the welds in a lab, testing how much energy was required to bend, stretch, and break them to make sure the joints would hold. The shipbuilders wrapped up the paint job, installed the pairs of 43,000 horsepower engines and two 70-ton propellers, and completed the electrical wiring and controls. The Triple E was ready for its first test at sea. Titans of the waves. The first Triple E class ship, for 400 meters, 1,312 feet, long, weighing nearly 60,000 tons, and able to carry more than 18,000 containers, passed its sea trials with flying colors. In July 2013, it set off on its maiden voyage. Since the Maersk has built 19 sister ships of the same type. There are many places the Triple E can't sail because of its enormous size. The most limiting constraints are ports and waterways, says Jay Falls, a naval architect with the U.S. Naval Academy. Some passages are too narrow or shallow for such colossal ships. Many ports don't have cranes large enough to reach across the biggest ships, adds a naval architect Paul Miller, also of the Naval Academy. And even on the open ocean, the limited strength of materials like steel puts constraints on designs for ever larger vessels, says naval architect Matthew Werner of the Webb Institute in New York. Despite these limits, the Triple E didn't hold the title of world's biggest ship for long. In late 2014, China Shipping Container Lines launched the Globe with a capacity of 19,100 containers. Then, this year, the Mediterranean shipping company Oscar headed to sea, setting a new record at 19,200. Its owners and crew had better enjoy the title while it lasts. Shipbuilders are building the next seagoing monsters, able to carry more than 20,000 containers right now. Number 1. What inference can be made about how the creation of the Triple E affected the shipbuilding world? A. Other shipbuilding companies copied the design of the Triple E and made their own similar ships. B. Other shipbuilding companies attempt to make larger container ships that move faster. C. Other shipbuilding companies were able to design even larger container ships and more continue to do so. D. Other shipbuilding companies have built larger ships capable of landing at most ports, even those with narrow passages. Number 2. How many containers can the Mediterranean shipping company Oscar carry? A. 19,000, B. 19,100, C. 19,200, D. 19,300. Number 3. A main reason why Maersk wanted to build the Triple E is because A. They wanted to be able to ship more containers at a faster speed. B. They wanted to reduce the cost of sailing container ships. C. They wanted to build the world's largest container ship. D. They needed to be able to ship larger items across the sea. Number 4. Read the paragraphs. The main ingredient in a container ship is steel. The Triple E contains more than 50,000 tons of it, enough to build 8 Eiffel Towers. Steel is an alloy or mixture of iron and other elements, especially carbon. For the Triple E, the shipbuilders ordered steel mixed to their exact specifications from a mill near the yard in South Korea. They needed just the right recipe to make the steel tough enough to withstand brutal waves. Steel that's too brittle can crack under the strain and sink a ship. At the shipyard, automated machines called plasma cutters used gas superheated to 16,000 degrees Fahrenheit to slice the steel. Robots welded the cutouts, joining them together by melting the edges to form giant segments of the hull called megablocks, 24 in all. A crane lifted the finished megablocks into place, and another set of welding robots melted them together to complete the hull. Maersk engineers checked the strength of the welds in a lab, testing how much energy was required to bend, stretch, and break them to make sure the joints would hold. Which detail best supports the main idea of these paragraphs? A. Steel is an alloy or mixture of iron and other elements, especially carbon. B. For the Triple E, the shipbuilders ordered steel mixed to their exact specifications from a mill near the yard in South Korea. C. The shipbuilders needed just the right recipe to make the steel tough enough to withstand brutal waves. D. Maersk engineers checked the strength of the welds in a lab, testing how much energy was required to bend, stretch, and break them to make sure the joints would hold. Number 5. Why does the author quote Michael Hyman throughout the article? A. He is the person responsible for deciding on the design of the Triple E. B. He is responsible for finding ways to cut fuels to cut fuel use on large ships. C. He is a naval officer who tested the speed at which large ships could travel. D. He is responsible for how the company tested the steel for the ship.